Nowadays, more and more newly released Wi-Fi devices start supporting Wi-Fi 6E. At Ubiquiti's website, we can see currently there are 2 UniFi access points which support Wi-Fi 6E. I believe in the future, many, if not all, access points will support Wi-Fi 6E. If you purchase the new access point, and you want them to work smoothly with your existing Wi-Fi clients, you may encounter strange issues here and there. In this video, let's talk about an issue that happens mostly with the old computers or IoT devices. I'm going to demo and troubleshoot the issue in my lab environment. As you can see, I have a UniFi PoE switch connected with 2 UniFi access points. The U6-Enterprise supports Wi-Fi 6E and the U6 Pro doesn't. I'm going to use 5 different clients to see whether they have issue to connect to the Wi-Fi network. I pick one IoT device, a simple smart plug, not from Ubiquiti, 2 Windows machines, both pretty new, but one comes with a pretty cheap Wi-Fi card. The other one supports Wi-Fi 6E. I'm also going to use 2 Mac Mini machines. One is 10 years old and it doesn't support Wi-Fi 6E for sure. The other one is Mac Mini M1. It doesn't support 6E but does support 6. On the screen, you can see I already logged on to the 2 Macs and 2 PCs. For this smart plug, I won't be able to show you the status on the screen, but I can update you by checking its LED status about the connection. Okay, in the network controller, you can see the current topology. The 2 APs are connected to the PoE switch, and let's check the Wi-Fi SSID configuration. I only have one SSID active. It's broadcasting on all APs. I manually enabled 2.4 GHz and 5 GHz. I unchecked the 6 GHz on purpose because I want to show you the successful scenario where I only enabled these 2 radio bands. Let's check what's the connection status. By the way, I disabled band steering so that it won't be a factor for this video. And just to simplify this video, because I'm going to use captured Wi-Fi frames to troubleshoot, I forced the 2 APs to use the same frequency in each radio band just to simplify the Wi-Fi frame capturing. Also, I want to avoid the unnecessary compatibility issues. I set the 2.4 GHz by using 20 MHz channel width and the 5 GHz radio by only using 80 MHz. Of course, for 6 GHz, I want to choose 160 MHz. Pretty straightforward. And currently, the Z-test SSID is only broadcasting in 2.4 GHz and 5 GHz radio bands. Let me show you the current connection status in the 4 computers. Let's check the 2 Windows PC first. The left one is the one with cheap Wi-Fi card. As you can see, it's connected using 5G. For the right one, because I only enabled 5 GHz and 2.4, of course, this new one also connect in 5 GHz radio band, no problem. And for the 2 Mac machines, the left one is connected in 5G. The protocol is 802.1 AC, and the right one, the protocol is 802.11ax, which is Wi-Fi 6 or Wi-Fi 6E. Okay, everything's expected. And if we check the client information in UniFi controller, you can see this Wi-Fi clients as well. The last one is for the smart plug. Based on the current Wi-Fi configuration, there's no issue at all. Each single device can successfully connect to the Wi-Fi network, right? But the whole point of purchasing this type of new Wi-Fi 6E enabled access points is to use 6 GHz radio band, right? So let me enable 6G radio band and let's see what will happen. Let me go to the Wi-Fi configuration and enable 6G. Give it some time. Okay, the change is effective. From the network topology, you can even see for U6-Enterprise, now it is broadcasting in 3 different radio bands. We are good from the access points perspective. Of course, because of the SSID changes, I need to reconnect all the Wi-Fi clients, right? So I am doing it now. Let me start with the 2 Mac machines. Interestingly, they both pop up with the same question. Basically, it's saying, okay, initially you input the password to connect to the SSID, but the security setting was WPA2. Now you are trying to use it in WPA3. Are you sure? You know what? This warning already indicates the root cause. But let's discuss that later. For now, let me simply click join. Okay, they both connected without any problem. And then for the PC with good Wi-Fi card, if I click connect, it doesn't warn me anything. From the different behaviors, I prefer the Mac OS approach. At least it warns you something. But at least this PC works fine in the new Wi-Fi configuration. If we check the other PC which doesn't have a good Wi-Fi card, if I click the connect button, it asks me to re-input the password. I don't know why, but let me input it anyway. Okay, immediately it tells me cannot connect without any detailed problem. We already had one finding in the second scenario that this PC doesn't work. What's the reason? We will find out later. And about this smart plug, we don't need to manually do anything, but let me take a cell phone video to show you the LED status. Okay, it's showing solid red color, which means it does have Wi-Fi configuration, but it doesn't work and it cannot connect to Wi-Fi. Okay, in the second scenario, after we add the 6 GHz without changing anything else in UniFi network controller, all of a sudden 2 of the 5 devices stopped working. So see what those 2 devices need to connect to Wi-Fi. They need the respective radio bands, no change. They require the supported channel width, nothing's changed. And they have their Wi-Fi standard. Again, nothing's changed, and we didn't change the password, so it seems nothing's changed. It seems just by adding a 6 GHz should only impact the devices that do support 6G, right? Why this addition will impact these 2 devices only, and these 2 devices happen to be either computer with old hardwares or the simple IoT device. There must be some common things shared by these 2 type of devices. And now let's discuss the interesting warning we saw from these 2 Mac machines. It's about the WPA2 and the WPA3. Let's go to the network controller. Let's revisit our SSID setting. Go to Z-test1. See, currently we have the 6 GHz enabled, right? Let me disable it, enable it again, quickly switch between these 2 options. Then let's see what other changes happen. See? The only change is in the security protocol part. Okay, if I don't have the 6 GHz for security protocol, I can choose WPA2 or WPA3. But if I enable 6 GHz, I can only select WPA3 related protocols. I just want to enable 6 GHz for this SSID. It has to choose WPA3. WPA2 is not an option anymore. Now I believe you already know the root cause. Because of our 2 poor old devices, they are too old. They do not support WPA3. You are absolutely right. To confirm that, let's look into the Wireshark frames. To save time, I won't show you how I capture frames for Wi-Fi. I directly show you the 4 different Wireshark sessions for the 4 different time frames. The upper 2, they are for the smart plug. The left one is for the successful one, the one we did not have 6G enabled. And the right one is for the failure, the one we had 6G enabled. And the lower part is for the Windows PC. Similarly, the left one is for the successful one. And because there are too many frames in each file, I already got the hardware MAC addresses for these 2 failed devices from UniFi network controller. I mark them down here, and I also use them as filters in individual files so that we only see the Wi-Fi frames that we are interested in. Okay, let's check the very first one, the one for the smart plug when it worked. From these key messages, if you are familiar with Wi-Fi 4-way handshakes, you may already know this is for the authentication process. It means it's successfully connected. So before that, smart plug would do some probe request to get the current Wi-Fi environment. Especially, it needed to know the Z-test1 SSID information. Let's check this probe response. See the SSID is Z-test1, right? That's the exact one we wanted the smart plug to connect to. It is from one of our UniFi access points to this particular smart plug. I already highlighted this probe response. In the frame details, let me expand to the tagged parameters and then find the RSN section. This section is for security. See here, for the authentication key management, it supports PSK. If you are familiar with WPA2 and WPA3, you may know PSK is for WPA2. Basically, this probe response means the AP notifies the smart plug that okay, I support WPA2. So this is a good answer to the smart plug because it only supports WPA2. So that's why in the following communications, it will successfully finish the authentication process. That's why for this particular scenario, the smart plug didn't have any issue when connecting to the AP. Okay, so we are good about this part. This explains why it worked when we didn't enable 6G, right? Let's move on to the right part. This one is for the scenario where we did enable 6G and we already saw the effect. The smart plug couldn't connect to the AP, right? If we scroll from beginning to the end, I don't see anything like the left part about the handshakes, about the key exchanges. That means the smart plug even never bothered trying to connect because it didn't think it would work. Why? Let's check some random probe response. For example, this one. Similarly, go to the tagged section for RSN information. See here, the authentication key management is SAE. SAE is for WPA3. Once the smart plug received this probe response, what it means? It means it's no-go. The smart plug didn't need to try, because it knew itself it didn't support WPA3 at all. So it never bothered, it never tried. So that's why the device never successfully connected. Okay, you know what? For the PC, in fact, it's the exact same situation. In the left part, the authentication was successful. And in the right part, if you scroll from beginning to the end, you don't see any attempts trying to connect, because the PC simply doesn't support WPA3. Okay, it confirms our theory. So these two devices couldn't connect simply because of the authentication method, the security setting. They don't support WPA3. The reason is they are too old. Now we are at the end of the video already. So you may ask, okay, now I know the issue. How do we resolve it? I don't want to waste my money after buying the expensive Wi-Fi 6E supporting access point and only use it as a Wi-Fi 6 AP, right? The solution is very simple. If you do have very old computers or IoT devices, they don't support WPA3, you have to have dedicated separate SSIDs. For those SSIDs, you do not have 6G enabled. And then for your new devices, new computers, which do support WPA3, which do support 6G, you have separate SSID, you have the 6 GHz enabled. In that way, you use the same access point to support different devices. Okay, thanks for watching.